All right, so let's now learn how to test a hypothesis. So our title of the discussion here is testing a hypothesis. So in your learning in statistics up to this point, let me address a question here. I can raise a question that say, what is the proportion of iPhone users? Okay, so that's one question can be raised here. And so the intention of this question is to find out the population proportion, and that population proportion is the population proportion of iPhone users. I'm talking about the proportion of worldwide iPhone users. So we want to know what is the value of the population proportion of iPhone users. But unfortunately, we don't know. And it's hard to find the actual truthful answer. Another question can be addressed as following. Or what about we can ask, what is the mean pulse rate of human? All right. And so this here is aiming at looking for the answer to the population mean. It's a mu value. And at this point in your statistics learning, no one viewing this video should be unfamiliar with any of these population parameter. So we want to look for population mean value. Population mean value of pulse rate. We have a lot of living human beings out there, and any one of us is having a pulse rate. And so somebody's pulse rate is beating faster than somebody else's pulse rate. Somebody's pulse rate is beating slower than somebody else's pulse rate. But in the end, we will definitely have a unique population mean pulse rate. And so once these questions were being addressed, back to the question about the population proportion here, or the value of P right here, then somebody can say the proportion of iPhone users is 30% of the world. Or somebody else can say the proportion of iPhone users is 90% of the world. And somebody else disagree with both of those and say the proportion of iPhone users is 70% of the world. And there can be many more arguments. There can be many more claims. So the way how I see that, any of these statements here, it's a statement. That is a statement. This is a statement. This is also a statement. But any of these statements is only a claim. It's just a claim, and without evidential support. Same way that happens with the mean value. Somebody can rushly say, and rushly I mean without evidential support, without presenting any evidence, mu, or mean pulse rate of humans, is 100. How about BPM, which stands for beat per minute? Okay. So somebody can say mu equals 100 BPM. Somebody else can say mu equals 40 BPM. Or somebody else can say mu equals 80 BPM. Okay, but so mu equals 100, or mu equals 40, or mu equals 80. Any of these is only a claim. It's a value being claimed. So what I have addressed so far is any of these remains. And one more thing to emphasize, any of these are just simply being stated, but without any evidential support, any evidence being presented. And so without evidential support, any of these remain to be the null hypothesis. The kind of hypothesis So a statement in math or any statement you say is a hypothesis. But then any of these hypotheses are being made without providing evidential support. So we regard to them as the null hypothesis. And then formally speaking, or symbolically speaking, I should have said that. So back in these problems right here, null hypothesis, we use a symbol capital H with a subscript 0. 0 is kind of intending for no evidential support. And so this statement right here, as a formal statement, and to prepare for the kind of work we will be doing later, if anyone is making a claim that proportion of iPhone users is 30% of the world, then there we recognize a hypothesis, a null hypothesis, saying that our null hypothesis is saying, I put colon there, proportion, population proportion, that's why it has been the lowercase letter p, the non-hat version, p equals 0.3. That's how we formally and symbolically write a null hypothesis statement. Or with this statement right here, p equals 90%, or the person initially said 90% of the world was an iPhone user, then there we have another null hypothesis. Now these are nothing related. They just one person making this claim, another person making this claim. So these are all different null hypotheses. So we have a different null hypothesis here saying p equals 0.9. That's how we are formulating null hypotheses. So quickly, for example, with this one, this guy down here, we can have a symbolic expression that's h sub 0, say p equals 0.7. And then over here, these are hypotheses making claims about mean value. And before I'm moving on to these mean values and back to these are null hypotheses making claims about proportion value, population proportion. And so that's why here these are null hypotheses making claims about population mean value. So that same symbol can also be used here. Here in this statement, mu equals 100. It remains permanently as a null hypothesis. We have h sub 0 stating that mu equals 100 BPM, and I don't think we even need to write 100 BPM. This other statement is saying as a completely independent null hypothesis. We have another null hypothesis here saying that population mean value for human pulse rate, mu equals 40. And right here we can have another null hypothesis. H sub 0 here is saying that mu equals 80. And we can skip the units here, BPM. And so now for this problem about the proportion of iPhone users, we have so many different null hypotheses. So one null hypothesis is p equals 0.3. As for the proportion of iPhone users, we also had a different null hypothesis. H sub 0 can also say p equals 0.9 as a different null hypothesis. Or somebody else can also say h sub 0 is saying that p equals 0.7. Then for the other question about the mean value of the human pulse rate, we had a hypothesis saying that mu equals 100. We also had a different hypothesis saying, or h sub 0 was stating that mu equals 80 BPM. And we can also have a hypothesis saying mu equals 40. But really, what I need to really address and emphasize now is that as far as who is the truthful one, which hypothesis here is a truthful one, nobody knows, because we basically have no judgment. We have no basis for judgment. We cannot tell who's among these claims to be the correct one, because any of these without evidential support, any of these can be truthful or can be untruthful. And so, and just like that, over here for these null hypotheses is regarding about the mean pulse rate of humans here, then we have no way to decide, to judge which one of these null hypotheses is the correct one. And so it becomes an endless argument until now. We have to, so if we are now about to test any of these, so the point now is that any of these as a null hypothesis can be tested for its own truthfulness. So this null hypothesis p equals 0.3. If you want to find out how truthful it can be, we have to do a testing. This hypothesis, same way for now, right from start, we have no way to decide whether it's truthful or not, but if you want to find out, we have to conduct a testing. And same way here for any of these hypotheses, these null hypotheses on the mean value, then we also need to conduct testing to find out which one of these can be a truthful statement. And so far, any one of these null hypotheses over here and to the right hand side of my board here, any of these, it becomes an endless argument among who is right and who is incorrect. And so now for us, any of us here looking at these hypotheses, these null hypotheses, then we're going to have to look at some reality. And so now how about for the question about proportion of iPhone users, let me now bring up some reality. The reality here says in a sample of 396 cell phone users. Of course, being an iPhone user, we are among all cell phone users out there, because there are Nokia users, there are Samsung users. So we want to conduct a sample. We want to select a sample of 396 cell phone users, and this is what we found. So this is an actual reality right here. So in a sample of 396 cell phone, I missed out that word. So cell phone users. So in that sample, we found 300 of them, or iPhone users. And so now this sample description right here gives us a sample proportion. It's not, and we have learned long enough up until this point that this answer will never be the answer to that mysterious question, the actual population proportion of iPhone users. But this is how useful we can use as a sample. At least this sample is a reality for us. That for one reality, we found that in 396 cell phone users, we found 300 of them are being iPhone users. And this sample proportion in decimals comes out to be 0.7576. So this is a reality. Whatever we picked as a sample, we cannot lie about it and assuming that the data being given here is correct data, it's truthful data. So we have a sample, and now the idea now is that we can use this sample as evidence, because this sample came out from reality. So even though only one sample being collected so far, but we can use this sample as evidence to start making arguments against any one of these. So same way, for this question about the mean pulse rate of humans right here, we found out that in a sample of 74 people, mean pulse rate is 73.65 beats per minute. And that means what we have here is this 73.65 beats per minute right here. It's a sample mean. It will never be the answer to this population mean value. However, it will become very useful for our work here. 73.65 is a sample mean. And further, we know that we have a sample size of being 74. Capital N equals 74. And so now once again, if we would like to find out which one among these null hypotheses can be the truthful one, or which one among these cannot be accepted as the truthful one, then we are going to compare any of these statements claimed in these hypotheses, compare with the reality we've had. So our sample is our reality, and reality is the evidence. And so with the evidence we currently having in hand as a sample proportion for this question, sample proportion set 0.7576. If we use this sample to argue against our hypothesis, the first null hypothesis saying p equals 0.3, then obviously comparing with this claim being stated in one of the null hypotheses, or in this null hypothesis right here, then this sample as an evidence does bring up an argument that it should be generally above this claim value. So now for us here, for any of us, after seeing and observing the evidence, the sample, we're going to start making a counter argument. And the counter argument from us here, made from observing the evidence, the sample, we're going to start arguing that, hey, maybe the actual proportion should be higher than 0.3. So think about this logic right here a little bit, but we don't want to run into the same footstep of this person, because we are about to test against that person making this claim. So if we make another claim saying, why not p equals 0.5 or why not p equals 0.7, someone is going to test against us. So here we want to be smarter than that. We just simply want to reject this based on our evidence, but we don't want to point to any specific value. And so that's why this is now another argument here. And in the end, an argument is a statement, and a statement is formally a hypothesis. But this hypothesis has some evidential support. So we refer to this as far as a formal name. This counter argument that we make right here is being referred as an alternative. So we have an alternative here. An alternative hypothesis. And alternative hypothesis has the symbols H sub 1. So it's easy to understand that we already use the symbol H sub 0 for null hypothesis. Then H sub 1 is the counter argument. And so now in this way right here, the way how we formulate our symbolic statements now is H sub 0, looking at H sub 0, it argues that p equals 0.3. Then we argue that based on our sample, we come up with a counter argument, and that appears as our alternative hypothesis. H1 is saying that p is greater than 0.3. And so, same way, if we're looking over to the other question, the question about a population mean, we had a mysterious answer, but our evidence came out to be 73.65. So it's only a sample mean value, but we treat it as a reality, as an evidence. And this came out from a sample size of 74 people, a big group. And by the way, I should have also mentioned that the sample size for our sample proportion was 396. And so with this sample mean here, if we are now using this sample mean, if we're looking at our sample mean here currently that we have and compare that with the first null hypothesis we've seen earlier, where it was saying mu equals 100 beats per minute, then this sample mean as an evidence is now clearly showing that mu should be generally below 100. And once again, we want to be more careful than whoever made the statement. We want to be a little smarter by saying that, hey, generally our means here suggest, our sample means, our evidence here suggests that the general population mean of pulse rate here should be below 100. And once again, this is an alternative hypothesis. Alternative hypothesis. And just like how I described earlier, alternative hypothesis, we can use the symbol H1. So here we're promoting for ourselves a counter argument, and formally we call that an alternative hypothesis. So H1 in our situation here is saying that mu should be generally less than 100. And so in that way, how I explain what an alternative hypothesis is, then once again, if we, the one who owns this, the one who owns these sample values, and we're treating them as our evidence, then if we compare our evidence with the different hypotheses here, let's say among our list of alternative null hypotheses, we also had someone saying that proportion of iPhone user was 0.9. Then if we're using our sample as our evidence here again to compare with this particular null hypothesis, then we're going to come up with a counter argument as following. Hey, looking at our sample and compare with your claim right here, I feel or I suggest that it should be, for a proportion of iPhone user, it should be generally lower than 0.9. And right here, once again, this can be regarded as an alternative hypothesis, simply because after observing our sample and compare that with the claim value in the current null hypothesis that we're having here, then it makes sense that we should suggest the value for p being below this 0.9. And same way for mean value, for the question about the mean value, once again, we can still rely on our current sample as our reality, as our evidence, and comparing that with another null hypothesis. Let's say we had that hypothesis saying mu, the mean pulse rate of humans right here, equals 40. If we had that null hypothesis and comparing this sample as our evidence with this current stated null hypothesis, then we can come up with a counter argument that, hey, looking at the sample here, looking at our evidence, we suggest that mean pulse rate of humans should be generally above 40. So it's all about we're looking at the sample and compare with whatever the value being claimed in the null hypothesis. And this is another alternative hypothesis in respect to or relative to this current null hypothesis. So once again, to get anyone viewing this video comfortable with the idea, H sub 0 is regarded as null hypothesis. And this one right here is an alternative, a little bit of a long name, an alternative, sort of like an alternative way of thinking right there. That's why it's called alternative hypothesis. And these are the statements, these are the hypotheses about the value of a population proportion. And same way here, we regard to this H sub 0 statement as the null hypothesis. And this statement with an inequality here, we regard to that as an alternative hypothesis. And then let's draw out some generality regarding how we formulate null hypothesis and alternative hypothesis here. So null hypothesis, look in the way how it was written, and we've had a couple other ones before I came to these. But null hypothesis will always be in the format of an equation, an equality. So here it says P equals 0.9 or mu equals 40. Think about the person who makes a claim. Any person making a claim, that person psychologically wants to be the star, the one that catches people's attention. So make the claim, I claim that proportion of iPhone user equals 0.9, or I claim that the mean pulse rate of human is 40. But now for the person who owns the evidence, for the person who has the evidence, and start making a counter argument, start arguing against the other person, start arguing against those null hypotheses, then we want to be a little smarter. So think about, this is our statements right here. We are trying to argue against these null hypotheses. So we want to be a little smarter. So that's why we're going to be using the inequality in our alternative hypothesis. So alternative hypothesis will always have the inequality format. Not even an equal sign involved. It's only a strict inequality in any of the cases here. But and the idea, logically speaking, the idea here is simply because once we already saw that footstep, we disagree. The whole point of coming up with the counter arguments here is because we disagree with the null hypothesis. But once we disagree, then we want to be a little smarter by claiming a different zone of values rather than pointing out to another value where people can attack at us again. And so here we're going to be more wisely claim that suggest that the value for the population proportion of iPhone users should be generally below 0.9, or here we should be saying that the population proportion, the population mean pulse rate of human should be generally above 40. And so that's how it is. So why do I spend so much time talking about alternative hypothesis as well as null hypothesis, alternative hypothesis and null hypothesis, even though so we are beginning into our problem where we're testing a hypothesis. And so before you can successfully test a hypothesis, test any of these null hypotheses for its truthfulness, then we need to know for ourselves that what are we proving. So the alternative hypothesis is our goal, what we're proving, what we're suggesting, and so we have to defend ourselves. But then if this is what we are proving, then we're proving against who? We are proving against these null hypotheses. So it's sort of like it's our general goal right here. We know what we're proving, and we're proving against somebody else. We're trying to either make it clear that we need to reject, or we pointing out that we fail to reject the null hypothesis. And so that's why anytime before we can proceed into a testing hypothesis problem, we always need to be able to identify the null and the hypothesis, the null hypothesis and the alternative hypothesis. Same way here for a mean value. Before we can start into a testing a hypothesis, we have to be able to identify the null and the alternative hypothesis. And now that I have shown how to find, how important it is before we proceed into any testing hypothesis problem that we must identify as our goal here what we are arguing and what we are arguing against. So H1, the alternative hypothesis, is our own counter argument against somebody else's statements. But now, in reality, it's not always easy to identify these things, especially when we are reading a worded problem. And so now allow me in this part of the video lecture here is to point out how we can recognize our hypotheses and be able to identify our hypotheses from the wording of a given problem. So let's say right now, let's look at our proportion of iPhone users again. We still don't know an answer, but here is what we have as a worded problem. So now let's turn over to to my computer screen here. But right from the beginning, we have the description here says, in a sample, actually a sample of 396 cell phone users shows 300 of them are being iPhone users. So right there, that first piece of information is indeed indicating that we have a sample proportion. And so now allow me to kind of take everybody back to from scratch here, but we have a sample proportion being 300 out of 396, which is in decimal equals 0.7576. And of course, the sample size we used here in this worded description, according to the description there, is 396 for the sample size. And so in that way there, let's look at the next part of the question. But no, we don't need to worry for now about this phrase saying at significance level 0.01. I will get back to that and explain. But the main part, the main question here is, and that helps a lot of readers to understand that we're being asked to conduct a testing hypothesis problem, is right here. This question is this sample is the sample showing strong evidence. And for now also, you don't need to worry about what it means by being strong evidence. I will explain as we move on. But now, is the sample showing evidence that proportion of user is more than 30%? So, have a moment to read carefully this statement. Is the sample showing strong evidence that proportion of iPhone user is more than 30%? Proportion of iPhone users is more than 30%. So that means, logically speaking, this question wants us to prove that generally proportion of iPhone users, which is back on my writing screen right here, P, proportion of iPhone users, should be above 30%, or let's use a decimal, 0.3. So immediately we have an inequality statement right here. P is greater than 30% or 0.3. And think a little further logically here, that we come up with this argument P greater than 30 because if we're looking at our sample, it's 0.7576. So of course it's greater. That's why this argument is more likely that it came out after we observe the sample value, the evidence. And so to be consistent with how I explained earlier, then we must treat this as an alternative hypothesis, because again, what I explained earlier, alternative only came out after we observed our evidence and compare our evidence with some null hypothesis. And so here it's easier and quite direct, right out from the wording of the question, that we can immediately extract out our alternative hypothesis. So alternative hypothesis is right here, and once again it has an inequality being involved in the statement. So it's our H1. And so now think about it this way, and here's how I make my next argument in terms of how we can identify the null hypothesis right here. Because remember, being able to find the alternative hypothesis is only one. But 0.7576 itself, this sample that we're currently having, is greater than a lot of other values. It's greater than 0.5 for sure. It's mathematically, it's numerically greater than 0.5. It's greater than 0.4. It's greater than 0.7, and it's also greater than 0.3, of course. But why is this problem, now back on my computer screen here, why is this problem specifically asking us to compare this value of the sample with 0.3? So think about it that way for a moment. All right, and so now this is how it happens. We compare with 0.3, we want to prove against 0.3 because somebody must have claimed, I hope I spelled out my word out loud and clear enough, but the reason we compare our current sample value with 0.3 and trying to prove that generally proportion of iPhone users is above 0.3 simply because somebody must have claimed that P would be equal to 0.3. And there now we can see that once we can identify that somebody must have claimed and saying that P equals 0.3, that statement there can now be regarded as a null hypothesis. Let's now turn our attention over to what about when we're testing a hypothesis about a mean value, a population mean value. So let's say on my computer screen here, it said that pulse rates generally have a known standard deviation of 4 beats per minute, but that's for now. We don't need to be too worried about that yet. But the real part here is saying a sample of 74 people gives a mean pulse rate of 73.65. So with this part so far, we know that we now have a sample. Immediately we have a sample. And keep in mind, we don't know what our population value is. We only know we have a sample. And our sample has a sample mean 73.65 beats per minute. And with this sample, it is 74 people. So its sample size being 74. And again, the actual question that helps us identify the hypothesis is here. At significance level 0.01, we don't need to worry about that phrase right now yet. But the real question is asking, is our sample of pulse rates showing strong evidence that generally mean pulse rate should be greater than 65 beats per minute? So, greater than 65 beats per minute. Mu is greater than 65 beats per minute. Isn't it obvious of how this inequality comes right out from the wording being greater than, and you can see that the wording here is purposely put in capitalized the term like this, being greater than 65 beats per minute. And so greater than 65 beats per minute, it's, think about the logic again, similar to how I made that logic about the population proportion, the alternative hypothesis about population proportion. Here it looks like the logical flow here is that after we observed our sample, then we compare to somebody's claim, and now we can try to make some generality that our sample, and we're trying to make a proof. We're trying to prove that, or making a counter argument that the mean value, the general mean, population mean should be generally above 65. So that this statement here deserves its place to be regarded as an H1, the alternative hypothesis. And so that's how we recognize our alternative hypothesis in this problem, right out from the wording. And again, 73.65 in our sample is above a lot of other values. It's greater than 50, it's greater than 70, it's greater than 40, it's greater than. Why is this statement specifically comparing with 65? Why? And so now, once we realizing that truth right here, because the statement could have been generally greater than 50 or generally greater than 70, but why are we comparing directly? I mean, why are we comparing specifically with 65? Because the answer to that is because somebody must have claimed before we observe our evidence, that somebody must have claimed that mean pulse rate of humans is equal to 65 beats per minute. And that's why we have some disagreement after we observe our sample. And so now, looking back one more time at this expression right here, it's an equality. It has equal sign in it. This is a perfect statement for being regarded as H sub 0. And so now, no hypothesis in this problem saying that mu equals 65. We observing evidence, and we're going to start making a counter argument. H1, we are arguing that mu should be generally above 65. And so this is our statement, and this is somebody else's statement. Over here, this is our statement after observing evidence, and this is somebody else's argument. And so now we know that we're trying to prove H1. We will always try to prove H1 to be true, and once So the whole idea of the logic here is that we're trying to prove H1. But proving H1 also means the same as disproving H sub 0. So now we have learned already that these sample values are our evidences to help us proving against some null hypothesis. Okay? Then, and we also learned how we can extract, how we can be able to identify the two hypotheses as our goal of the problem here. So null hypothesis, when we were proving a population proportion value here, we have identified two hypotheses, null hypothesis and alternative hypothesis. Same here for the population mean value, null hypothesis and alternative hypothesis. But now back to the wording of the problem, it's now about time for me to explain, but why did it say, for example, in my sample about cell phone users here, then why did it say, is the sample showing strong evidence? Evidence is evidence. Why is it strong evidence? Or in the other problem about looking at our sample as evidence to prove against a mean pulse rate of human being 65, then why was the question saying that is our sample pulse rate showing strong evidence? So strong evidence again. I mean, we already had the evidence being 73.65, but why do we want to say that strong evidence? So what does that mean by being strong evidence? The idea now is that, and at this point of your learning in statistics, I have mentioned so many times and emphasized so many times that anytime you can pick up a sample, that means there are infinitely many other samples out there, provided they are of the same sample size. So that means the reason we're talking about strong evidence or not strong evidence is simply because, hey, maybe this is our evidence. Maybe this is our sample, but it's the only sample we have found so far. Maybe this sample shows a value above this claim value. Maybe this sample 73.65 shows a value above the claim 65. But who knows, if we search for another sample, then it's going to be if we search for another sample proportion value, then who knows, it's going to come down to 0.3 or 0.35, somewhere closer to this. Or who knows, if we search again for a different sample mean out of 74 people again, then it's going to come to some other sample mean that's closer to 65. Think about the person who made these claims, the people who made these claims. They can argue that way. That who knows, you guys only rely on only one sample. How can you guarantee that other samples will also come out generally higher, always higher than this? Because I have to emphasize that when you make your own alternative hypothesis, it also generalizes the fact that any other time when you pick other samples, you will generally find values or sample mean, sample proportion or sample mean being generally above this claim. Okay, and so in that way, strong means, hey, is there a way we can prove that this sample we have without the need to search for another one, or this sample mean that we have without a need for searching another one, we can still prove for solidity that it will always generally be above 0.3 for the proportion value and being above 65 for the mean value. And that's what being strong evidence is all about. And so now looking back into the wording of the problem, the entire question now is asking, is the sample showing strong evidence that proportion of iPhone users is more than 30%? And so think about the logic this way. The question is indeed only a yes or no question. So you can either say yes, but yes for what? Yes if we have strong evidence, if this evidence we have here is a strong evidence to help us support and prove this statement and reject the other statements. Same way, in the problem where we are about to test the hypothesis for about a population mean value, the question is stating, is our sample a pulse rate showing strong evidence that generally mean pulse rate should be greater than 65 beats per minute? And so ultimately speaking, that question there, the wording in front of you, is again a yes or no question. Finding yes or finding no depends on if we have strong evidence, if we can prove that our evidence, the only evidence we've had and we need here is it's strong evidence. If we can prove that it's a strong evidence, then we say yes. If not, if we fail to prove this is strong evidence, we say no. So now generally as an impact on any of these hypothesis testing or any of these testing hypothesis problems, think about we have a null hypothesis and we observe our sample, our evidence, whatever evidence that is, and we have a counter argument, we have an alternative hypothesis. So if we have strong evidence, if we can prove that we have strong evidence, it also means the same as we can successfully support H1 because we can prove it, and also means the same as we can successfully reject H sub 0. But that's about all we're saying. We're only saying that we can support, we have strong evidence to successfully support H1, or we're saying that we have strong evidence to successfully reject H sub 0. I shouldn't use these two double head arrow. It might be a little bit logically complicated for anyone who is not who hasn't done too much. But how about strong evidence for the purpose to successfully support H1 or to successfully reject H sub 0? These are always two equivalent statements. That's when we have strong evidence. And then having strong evidence is where we say yes, we give the answer yes to the ultimate question. And then if we fail to prove that our evidence is strong, so there will be times that our evidence turns out to be not strong evidence. So our evidence can be not strong, and evidence being not strong leads to, so this time I have to use that arrow over here, it leads to we're going to be failing. We're going to be failing to support. We're failing to support H1. And also means the same as we're failing to reject H sub 0. And this is where we answer no to the question, our ultimate question. Is the sample showing strong evidence or not? Is the sample showing strong evidence to generally say that mean value is above 65 beats per minute, or the population proportion is generally above 30% of the cell phone users to be iPhone users? And another thing I need to emphasize, the last thing we need to say here is that we can support H1. We're not going to say absolutely H1 is the truth. We're not going to say absolutely the alternative hypothesis after observing the evidence is the truth. We're not going to say it that way. We're trying to put things in a nicer way. We're saying that we have strong evidence to successfully support H1. And then further consequence, we're saying that we have strong evidence to successfully reject H sub 0. Notice how nice how the wording here is. We only want to say to people that we have to reject their hypothesis. Whoever made that claim, we only tell that person that we are rejecting your statement. But we're not going to say that, hey, you are wrong. We're playing nicer. We're doing nicer work than that. And so like that. Another thing to understand, when we don't have strong evidence, when we're not having strong evidence, of course we fail to support H1, but that still does not mean H0 is correct. So that's why the safer way of saying that is we're failing to reject H sub 0. But instead of saying h sub 0 is correct. We have no basis to say that h sub 0 is correct. We still have no basis to say h sub 0 is correct. All we can say is if our evidence is not strong, all we can say is we fail to reject h sub 0 or we fail to support our own argument.